planning agent is the first intelligent component that receives the user's query. Rather than immediately searching for information, it first tries to understand the user intent. The first stage is query understanding, where the agent extracts the main objective, identifies important financial identities, such as company names and fiscal years, and determines exactly what information the user is requesting. Next, the query moves to information need decomposition. Here, the planning agent breaks complex questions into smaller information requirements. For example, if user asks for an investment analysis of Tesla, the planner identifies that it will need financial statements, business performance, risk, future outlook, and market sentiment. After identifying the required information, the agent performs plan generation. It decides which specialized agents should be involved, determines the execution sequence, defines the required data sources, and specifies the stopping conditions for the workflow. Finally, the planning agent outputs an execution plan, which is passed to the orchestrator. The orchestrator then coordinates the remaining agents according to the predefined workflow. This design separate planning from execution, making the system more modular, deterministic, and easier to debug. Then, once the execution plan has been created, the search agent is responsible for acquiring the necessary information. The search agent does not directly answer questions. Instead, its goal is to retrieve high quality supporting evidence. The process begins with query generation based on the missing information identified by the planning agent. The search agents use an LLM to generate multiple document-oriented search queries. These queries are then passed to the source discovery stage. The system searches trusted financial resources such as Sec Edgar fillings, company investor relations websites, annual reports, quarterly reports, and other authoritative financial databases. After identifying candidate documents, the document retrieval stage downloads the relevant files while validating accessibility and removing duplicate results. Next, the content extraction module processes the retrieved documents. PDFs or parsed, tables are extracted, text is chunked, metadata is attached, and everything is prepared for embedding into the vector database. Finally, relevance assessment stage evaluate the retrieved content using semantic retrieval and re-ranking techniques. Only the most relevant evidence is returned to the orchestrator for downstream tasks.
After Planner Agent decided the query as QA, the RAG model systems is triggers. This is the instructions pipeline, where documents are chunked by title into three types: image, table, and text. Then they would be embedded into vectors by OpenAI's embeddings and stored in Superbase. The table and image are pushed through VLM to enhance the content, so the embedding vectors from then will be more meaningful and related to the query. There is the retrieval pipeline, which is involved with hybrid search, combining keyword and vector search, before pushing through reciprocal rank fusions layer to get the top chunks. If needed, the search agents is called the search agent will be called to get informations. If the query is classified as deep advice, the multi-agents will be triggered. The four other agents work together to supply the report for users. Advisor agent has tools for business analysis with calculation formula for providing financial outlook. The critic one will find the logical error in reports of advisor, listing out the list of identified issues. And finally, the evaluators is the final output gate for the answers, where it will evaluate based on the reports. Based on the reports, the queries, and the bullet points of critics. in order to assure that advisors, after several times of report improving, has provided the most relevant and significant report. If it is not okay, the search will be called the advisor, the critics will be called against. And all the agents obviously have the internal reasoning mechanisms to revise the answer before pushing that information out. Obviously, there will be preventions for infinite loop. The max version of the report in this application is advisor version 3, meaning the loop iteration maximum is 2. So the agents have tools to support each others. However, we cannot configure the output of the agent to the input of the next one, which would make the input token to LLM increasing considerably after every agent interactions. That's why we need a shared memory here. To store the general information. From that, we will have two types of memory, which were first is the short-term memory and the long-term one. To maximize the amount of input token, the short-term memory is divided into 4 sections. Uh, the context, the retrieval logs, the critic arguments, and the advisor report. From that, the agents can flexibly interact and just get the information that they need, not all of them, and for each sections only. The next one is the long-term memories. The ERD is designed to support 3 categories: the user preference memories, the conversational, and the key statistic one, and the entity fact one. The first one is the conversation. It's just configured to remember the 10 latest record of the message. The second one is user preference. Remember 2 types of answer user want to be delivered. And the third one, the most complicated, is the entity facts. We store the key statistic memory of the conversation. The key data is stored at JSON in key value pair form. However, we cannot deliver all of records or the 10 latest one because that would be too much. So I decided to push its record through LLMs to extract the fact text, which destroys the key data and embedding this text into vectors. From that, we can use the cosine functions of RAG to implement vector search and find the most 10 significant statistic related to the query. Here on, I will show you the demo of the website. After logging in, you guys can create the projects if we are admin, and from that we can upload the documents for RAG or for the provide the information for the multi agents, and from that we can create new conversations and ask them everything. The results will be delivered through the multi-agent systems if it is with the tools, and if there is something misinformation, the search agent will call.
Today, I'm presenting our AI evaluation system, specifically how it's designed whether a revised report is actually better than the original. Our tagline for this is better isn't score, it's proven. That's the whole idea I want you to walk away with. We didn't build a system that rates report, we built one that proves whether specific problem got fixed. So let's start with why this is even a hard problem. The obvious shortcut would be show an LLM both report and add it to pick the better one. We wouldn't go that route for 3 reasons. First, it's unauditable. There's no traceable reasoning trends, so you can verify why one report was chosen over the other. Second, it's inconsistent. The same LLM can pick differently across repeated run on identical inputs. And third, it's easily gained confidence. Fluent pros can fool a naive judge regardless of whether the actual content improved. So instead of asking a model to judge quality, we ask can we turn better into something measurable and reproducible. That's where our 3 agent pipeline comes in. First, the advisor agent generates the initial business report one based on the user query that's handled by the run test look dot by just for the test. And then the critic step 2 is that the creative agent audit that V1 report and write a checklist, runs for audit tools, and synthesize its finding into a fixed Excel to resolve checklist. And critically, this checklist is created before version 2 even exists. It becomes our objective yardstick. The last step, that is, the advisor revises version 1 into version 2 using that checklist. That's where the run test loop to drop by. Then the evaluator runs deterministic checks comparing V1 against version 2 to verify the checklist will actually resolve. So that is where the run test loop with metric come in. That is the evaluator agent. So the pipeline isn't just generate then judge, it's generate, audit, revise, and verify. And that last step is where better actually get decided. So let's zoom into the critic step because this is the foundation everything else depends on. The critic runs for audit tool on the V1 report. First is the report correct tool. It checks whether the report covers all topics and themes required by the original query. Second one, that is the evidence consistency tool that verifies that claims are backed by consistent evidence and flagged by anything unsupported. The third one is the risk gap tool, which is identify missing risk disclosure gaps in the report's risk assessment coverage. The last one is the figure audit tool, which will audit the numerical figures and data points for accuracy, consistency, and proper citation. The findings from all four get synthesized into the fixed checklist. And the key point here is happened before revision, so by the time version 2 exists, we already have a lock-in, objective list of exactly what needs to change. We are not comparing two reports in the abstract, we are checking whether version 2 closes a specific redefined set of gaps. So once the checklist exists, the next file will, that is the advisor, will take over again. So for the input, it runs the original version 1 report alongside with the critic checklist of issue to resolve. When it's processing, the advisor agent will write the whole report, capturing each checklist item in the issue to resolve. Important to note that no evaluation or comparison happen at this stage because the advisor will generate again the report. The advisor isn't checking its own work here, it's just revising all the report. So the output is a revised version 2 report. And I want to stress here, no better decision gets made in this step. Version 2 at this point is just a candidate. It still has to earn its verdict from the evaluator. So the evaluators, there are four tools. First one is query relevance tool, checks whether version 2 covers the topic and intent implied by the user original query. Next one is the response completeness tool, which verifies the structural pillars are present, citation, limitation, and actionable advice. Next one, we have the issue to resolve resolution tool. It is the core one. It checks whether version 2 resolve each checklist item from the critic agent raised against version 1. And last one was the evaluation query tool. It's a self-check. The evaluator whether it's all output before running the final verdict. And of these four, the issue resolution tool is doing the heavy lifting for our which version is better question. So let's look at exactly how it works. The actual math behind the results is that step by step we have the keyword extraction, which use the function issue resolution tool. It price each checklist item and extract the significant keyword. Next we have the stop word removal. So common words like the, is, get stripped out first. So only domain relevant terms drive the matching. Next one we have the coverage formula. It will equal the match keyword divided by the total significant keywords. If that ratio is 0.5 or higher, the issue count as result in version 2. Last one is the deterministic and reproducible. There's no subjective LLM judgment anywhere in this calculation. It's pure rule-based keyword matching, which means every vertex is transparent, reusable, and run it twice on the same input. You get the answer both times. Next one, we have the verdict. So always fill into the final verdict. The system return verdict is pass or fail, and that verdict is deterministic. Version 2 has to demonstrably close the V1 gap, so not just sound more polished or confident. Backing that verdict are three checks. First one, all ISO result confirm every critic checklist item was resolved in the version 2 using the keyword coverage matching we just worked through. The next step is that the all topic cover verify the version 2 address everything implied by the original user query, no gaps allowed, and response complete check that the structural pillars, citation, limitation, actionable advice are all present in version 2. So when we say version 2 is better, what we actually mean is it passed all three of these checks against a checklist that existed before it was written. So two last thing I want to leave you with is that first, an honor caveat. There's a separate optional weighted scoring layer uh, in the file when we run the agent for evaluator. It adds an LM based score from 0 to 100 across seven weighted criteria like financial accuracy at 25 at most, business analysis and risk assessment and at 15 each, actionable advice also at 15, evidence usage, completeness, and query satisfaction at 10% each. This is generally useful for demos and stakeholder-facing reports, but I want to be clear, it's not part of the core evaluator verdict. The pass and fair decision never depends on it. Second, why we build it this way so that every calculation is delegated to the deterministic Python. No LM arithmetic anywhere in the core logic. Self-review loop enforce the structural completeness before any output is returned. And the result is full audit trail, every verdict link directly back to the specific checklist item and specific keyword collection number, fully reproducible end to end. So that's the system